Next, we talk about shrinkage type and selection. You know that the purpose of the shrinkage is to measure the strength. We are interested with the strength of the test specimen, but what you are actually measuring is the strength that you acquire from the shrinkage. And the strength is determined by quantifying the differences in terms of the electric resistance occur due to the deformations of the strength. Now, to make the measurement accurate is not an easy task. A lot of factors that you have to consider. It is not as easy as you attach a strain gauge there, connect it to data logger, and acquire the reading straight away. You cannot guarantee the accuracy and reliability of the measurements later. There are two main factors that affecting the accuracy in terms of the strength measurement. First, you will have to select the right strain gauge. Second, you will need to install the strain gauge correctly. Any of these two items is not fulfilled, the result as acquired from the strength measurement would be skeptical. Now, what does it mean by selecting the correct strain gauge? You have to consider for the test specimen material, the operating environment, as well as the dimensions of the strain gauge. It is only you have all this in place, accurate strain measurement is possible. The term here is possible. It is not guaranteed, as there are also instances where actual measurement does not proceed as anticipated due to the measurements condition. The specimen itself can impose a variety of limitations. For example, when you want to use a heat curing adhesive but heating the test specimen is problematic, or when you want to use a weldable gauge but the test specimen material is difficult to weld, or when the amount of coating required to waterproof the gauge causes structural problem with gauge functioning. This may affect the ability of strain gauge to do accurate measurement. You should thoroughly examine the test specimen as well as the measurement environment before selecting appropriate strain gauge. There are many types of strain gauge. Each have different purposes and features. In general, it can be classified into four broad groups. First, it will be the testing temperature. There are applicable range for the strain gauges. Some are suitable for low temperature. Some are for normal temperature, high temperature, and super high temperature. The strain gauge can also be classified based on the materials of the test specimen. These include the metal, concrete, wood, plastic, composite material, glass, and etc. Strain gauges can also be classified based on the special uses, whether you need it with large elongations, stress concentrations, residual stress, boat axial, magnetic field, torque, and etc. The last one is the transducer use, whether it is high resistance or diaphragm, and etc. The second criteria of strain gauge selections is the size of the strain gauge. This is sometimes dependent on the locations of the strain gauge to be installed, as well as the materials that you intend to measure. Not only that, you might need to consider the space required for the coating when determining the gauge size, as normally the lead wire will need to be connected to the connecting terminal. Something like this. You have a typical strain gauge. It doesn't come with the wires. You will need to do some soldering in order to connect the strain gauge to the wire so that it can be connected to the data logger. Now you will need space for you to place the terminal and also for you to do the soldering. This is how you do the soldering. You need to be able to access the shrinkage, which has already been installed to your test specimen. This requires space. Or you need to consider the space required for the coating applied to protect the gauge from moisture. With that, determining the suitable size of the strain gauge is important. Another thing that you need to consider related to the strain gauge size, it will be the gauge length. This is referring to the length of the sensitive element in the strain gauge. Depending on your test specimen, different gauge length is selected. Now, short gauge lengths are used for local strength, while long gauge lengths are for average strength over a large area. You may refer to the table here for the applications of strain gauge with different gauge length. For strain gauge with a gauge length of 0.2 to 1 mm, it is normally used to measure the concentrations of the stress. This is very narrow in fact. You will need to select the locations of the measurement carefully for you to be able to pinpoint and measure the strength that is later converted into the stress. As for metals and general use, the suitable gauge length it will be between 2 to 6 mm. For mortar, wood, and FRP, FRP stands for fiber reinforced polymer. You may use gauge length of 10 mm to 20 mm. As for concrete, you can use gauge length of 30 to 120 mm. These are some tips that you can consider while selecting the suitable gauge length. For heterogeneous material, the meaning of heterogeneous is that this kind of materials are normally composite, where the content have diverse character. One of the examples of this kind of material, it will be concrete, which is made of cement paste and aggregate. Now, if you're dealing with this kind of material, due to the diversity of the properties of their compound, measuring local strength become not representative. When this kind of material is subjected to load, stress normally will concentrate at the weaker compound, progressively damage the weaker compound, which at the end of the day, the entire specimen fails. Taking the concrete as an example, we know that the aggregate is very strong. The weak part is normally the bond between the aggregate and the cement paste. Now, how can you tell the concrete? Where are the possible places that gives you high stress that ultimately may go beyond the strength of the material and leads to the failure of the material? In that case, it is more suitable of you to determine the average out of irregular strength in the material. That means the shrinkage should cover a wider area in order to acquire the average value out of the measured region. Again, taking the concrete as an example, the gauge length normally is selected to be at least 3 times the diameter of the aggregate in order to acquire an average value of the concrete. Let's say now the largest size of the aggregate is 20 mm. 3 times 20, that means you require strain gauge of 60 mm at least. It looks something like this. Next is about selecting the gauge width. Strain gauge with same gauge length are also available in the narrower width, something like this. This is FLA series. and this is FLK series. Then you will have to consider which one is more suitable for your test specimen. Next, we talk about the strain gauge shape. There are strain gauge in different patterns for a range of applications. You will need to choose the appropriate strain gauge for your testing. We have single element strain gauge. We have two element rosette strain gauge. Among these two, there are staggered type and plane type. Staggered type have the center of the two strain gauge, which is arranged in the perpendicular directions, lay on top of each other. The center of both strain gauge, it would be center here. Now the plane type here has no overlaying of the two strain gauge. They are also arranged in the perpendicular direction. Now the axis meet at this point here. Depending on your measurement, you need to select the suitable one. You have also 3 element rosette type. You have an additional axis in 45 degrees. Again, there are staggered type and also plane type. Choose the suitable one. Last, you have 5 element single axis. You have 5 units of strain gauge arranged in the same directions at a constant offset distance between each other. Personally, I have not encountered this, never used this before. However, based on the arrangements of the strain gauge, it is meant to measure one directional strain, which is in these directions, over a regions of area. Most likely it is used to measure the tearing damage or cracking of the test specimen passing through these strain gauges. With proper measurements, when the crack passing through this, you are able to quantify the rate of progressions of the respective damage. If you have experience of using this, feel free to share your experience and enlighten me regarding its applications. I have never used this before. Next, we look at the strain gauge operational temperature range. This one we have established previously. Strain gauge is very sensitive with the temperature. Should the strain gauge is applied under the environment with the temperature other than 20 degrees, it is likely that you have to do some corrections in terms of the gauge factor as well as the thermal coefficient. As long as there is no structurally caused change happening to the strain gauge, it should theoretically be applicable. You may also refer to the curve given in the notes that comes together with the package of strain gauge to determine the applicable range for the relative strain gauge. Or you may refer to the table here. There are low temperature, normal temperature, high temperature, and super high temperature. Now the definitions of this temperature are listed here. Low temperature is referring to negative 269 degrees Celsius to the room temperature. Normal temperature refers to negative 20 degrees Celsius to 80 degrees Celsius. High temperature can reach up to 200 degrees Celsius and 300 degrees Celsius, depending on different types of alloy. And super high temperature can go up to 800 degrees Celsius. The strain gauge is made of platinum tungsten alloy. Now the material of the gauge base differ by the range of temperature. This is the gauge base. Epoxy resin can be used for normal temperature and lower, Meanwhile, polyimide resin can be used for higher temperature. In terms of the strangest series, it is listed here. For normal applications, normally we use F series. Most of the testing related to civil engineering structure will be using this F series. Next, we talk about the self-temperature compensated strain gauge. There is a series of coefficients of linear thermal expansion. The most commonly used are these three. TML identify them by using the gauge base of different colors. You have red, brown, and green. The one that normally we use are the red. That means it is referring to 11 times 10 power of -6 strength per degree Celsius. This table serves as a guide to selecting a strain gauge for ordinary strength measurement. These are the criteria, which include the testing temperature, test specimen material, strain distributions, the measurement purpose, as well as the type of the test. Considering the test temperature, you are selecting strain gauge based on the series. You will need to select a strain gauge series capable of functioning at the testing temperature. You may refer to this table for you to determine a suitable series for the testing. Second, you are talking about the test specimen material. Now you select the strain gauge in terms of the self-temperature compensated strain gauge. Select a suitable one for the specimen. The self-temperature compensated gauge are commonly used to minimize the gauge thermal output when bonded to the test specimen. This thermal output will need to be within the acceptable range of ± 1.8 times 10 power of -6 strength per degree Celsius. Next, you need to consider regarding the strain distribution. This one, you have to consider the gauge length and the width. Select the appropriate gauge size for the measurement purpose based on the strain distributions and material. And then about the measurement purpose, you need to look at the gauge pattern. These are the typical gauge pattern, each serving different purposes. You have single element, 2 element rosette, either staggered type or plain type, 3 element rosette, staggered type or plain type, and 5 element single axis. Lastly is about the type of the testing. We are looking into the measurement method. The strength measurement methods is referring to this. There are various ways to measure the strength. Each serve different purposes. For more detail, you may refer to the relevant references.